Now convert the minimization into maximization just by multiplying through the negative sign. Minus 10x1, minus 6x2, minus 2x3. All the coefficients of the variables are 0 except for a1 and a2. The coefficients of a1 and a2 are minus 1. Now using this identity matrix and the variables a1 and a2 and the coefficients of a1 and a2, we are going to construct the first initial simplex table. Hello dear students, welcome to this session of our class Operation Research. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the problem based on two-phase method. So the steps and how to solve the problem. We have considered one example to solve the problem in LPP using two-phase method. So in this session also I am going to take one more problem which can be solved using the method of a two-phase method. Now, solve the following LPP using two-phase method. Example number 2. So, the name itself indicates there should be two phases. Now, verify the first phase. So, now what is the problem given? The problem given is minimum z is equal to 10x1 plus 6x2 plus 2x3 subjected to the constraints minus x1 plus x2 plus x3 greater than or equal to 1. And 3x1 plus x2 minus x3 is greater than or equal to 2, and the non-negative restrictions x1, x2, x3 are all greater than or equal to 0. Now just observe the problem given is minimization problem. Now we have to convert this minimization problem into maximization problem just multiplying all the coefficients by negative sign. Now convert this minimization into maximum z. Max z, we can write z bar or we can also write max z star. So here this can be written as just multiply by negative sign. If you multiply by negative sign, we will get the objective function max z dash or z bar is equal to minus 10x1 minus 6x2 minus 2x3. This is the objective function. Okay, now convert the minimization into maximization just by multiplying through the negative sign. Minus 10x1 minus 6x2 minus 2x3. Okay, and convert these inequalities into standard form. So the inequalities can be written as minus x1 plus x2 plus x3, and we are going to add slack variables s1 and slack variables, surplus variables as well as the artificial variables. Now, minus x1 plus x2 plus x3 minus s1 plus a1 is equal to 1, and the second equation is 3x1 plus x2 minus x3 minus s2 plus a2 is equal to 2. And the non-negative restrictions are x1, x2, x3, s1, s2, a1, a2 are all greater than or equal to 0. Now let us convert this into the standard form. Now considering the standard form of the equation, so to construct the first phase, we have to take all the coefficients except a1 and a2. All the coefficients of the variables as 0 except for a1 and a2. The coefficients of a1 and a2 are minus 1. Now constructing the standard form, the objective function is written with 0 coefficient for all the variables except for artificial variables. Whereas for artificial variables, the coefficients are minus 1. This is very important. In phase 1, the objective function is written with 0 coefficients for all the variables. So therefore, the max z dash or z star is equal to 0x1 minus 0x2 minus 0x3 plus 0s1 plus 0s2 minus a1 and minus a2 except for artificial variables a1 and a2 as minus 1. And the constants are converted into the standard equation, and the constraints are as usual minus x1 plus x2 plus x3 minus s1 plus a1 is equal to 1 as I have written here, and similarly the same equation 3x2 plus x2 minus x3 minus s2 plus a2 is equal to 2. So this is the standard form. Now let us construct an initial simplex table and verify whether the optimality will exist or not. Now before that, let us write down the coefficients for this. Write down the coefficients x0, x1, x2, x3, s1, s2, a1 and a2. for these equations. So for the equation, coefficient of x0 is 1 and 2 for equation 1 and 2. Here it is -1, x2 is +1, +1, s1 is -1, s2 is 0, and a1 is 1, a2 is 0. Again for second equation, x0 is 2 and the values of x1, coefficient of x1 are 3, x2 is 1 and the coefficient of x3 is -1 and s1 is not there, s1 is 0, s2 is -1 and a1 is 0, a2 coefficient is 1. Now let us see here, this a1 and a2 will form an identity matrix 1 0 0 1. This is an identity matrix of order 2 rows and 2 columns. So these are the initial basic vectors. So 1 0 0 1. So the variables here are a1 and a2. Now using this identity matrix and the variables a1 and a2 and the coefficients of an a1 and a2, we are going to construct the first initial simplex table. So in the first initial simplex table, initial vectors are a1 and a2 and the coefficients of a1 and a2 are -1 and -1, -1 comma -1. And here the values of x0, x1, x2, x3, s1, s2, a1 and a2 from the standard equation is the coefficient of x1 is 0, x2 is 0, x3 is also 0, s1 is 0, s2 is 0, whereas a1 and a2 are -1 and -1. So, and write down the values. So, I will straight away put these values, the constraints. So, substitute these values. What we will get? x0, 1, 2. Here it is 1, 2, -1, 1, 1, -1, 1, 1. Then -1, 0, -1, 0 and again 1, comma 0. Similarly for the second equation, 2, 3, 1, 2, 3, 1, -1, -1, 0, -1, 0, 1, 0, -1, 0, 1. These are the values. Okay, just verify it. So 1, -1, 1, 1, -1, 1, again 1, -1, 1, -1, 0, 1, 0, 0, 1, 0. Now for the second equation, 2, 3, 1, -1, 2, 3, 1, -1, again 0, -1, 0, 1, 0, -1, 0, 1. So these are the value. Now as usual, just find out the value of Zj and then delta j, that is Zj minus Cj. Now what is Zj? Zj is nothing but just multiplication of these two. So multiply this. -1 into -1, -1 into -1 is -1, -1 into 2 is -2, this is equal to -3. Next, -1 into -1 is +1, again -1 into 3 is -3, that's equal to -2. Again, -1 into 1 is -1, -1 into -1, -1 into 1 is -1, -1 minus 1 is -2. Again, -1 into 1, -1 into 1 is -1, again minus into minus +1, this is equal to 0. Again, -1 into -1 is +1, 1, again minus into plus it is 0, this is equal to +1. Again, -1 into 0 is 0, again -1 into 0, minus into minus +1, this is equal to +1. Again, -1 into 1 is -1 plus 0 is -1, -1 into 0 is 0, -1 into 1 is -1. So these are the values. Now find out the value of delta j. Delta j is equal to Zj minus Cj. Now what is Zj minus Cj? Subtract this. So -2 minus 0 is -2, you will get. This is -2 again. 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 0 is 1. Again here this is -1. Minus of -1 is +1. This becomes 0. Again -1. This is minus of minus +1. This is also equal to 0. So these are the values of delta j. So hope you followed this. This is same as usual as like construction of initial simplex table. The procedure is same for this also. Now let us consider here in Zj we have two least negative values. So -2 and -2 are the two least negative values. Yeah, let us consider the first least negative, this as the incoming variable. So this is the incoming variable. X1 is the incoming variable. Let us round this. Now find out the ratio. Now the ratio is equal to, how to find the ratio? The ratio is equal to x0 divided by the incoming variable is x1. x0 divided by x1. Now what is x1? x0 is 1 divided by minus 1. 1 by minus 1 is equal to minus 1. And the second x0 is 2 divided by 3. 2 divided by 3 is nothing but 0.66. So, and this is as it is. Now here just find out the ratio. Here the ratio is nothing but x0 divided by x1. 1 divided by minus 1 is minus 1. 2 divided by 3 is equal to 0.66. Here the identify the least positive value in this row. Identify the least positive row. Here 0.66 is the least positive. So therefore this is the positive, this is the outgoing variable. Outgoing variables. So these are the outgoing variables. Let us encircle this. So the outgoing variables are A2 is the outgoing. So here A2 is outgoing, whereas X1 is incoming variable. Okay. Now let us come to the next iteration. Iteration number 1. What is the first step we are going to convert is find out the key element. Here key element is 3. Key element is equal to 3. Convert this 3 element as 1. So to convert this key element as 1, we are going to divide the entire row by element 3. So in the next iteration, the first operation we are going to use is R2 dash is equal to R2 divided by 3. Then convert this minus 1 as 0 using the elementary row operation. That's it. Okay. Now let us come to the next initial simplex table. In the initial simplex table, so A1 will remain the same. A2 is replaced by x1 and the coefficient of x1 is 0. Now let's come to the next table. Let us come to iteration number 1. In the iteration number A1 is as it is minus 1 and x1 is replaced by A2 is replaced by x1 and the coefficient of x1 is 0. Come to this R2. R2 is equal to, now R2 dash is equal to R2 divided by 3. What is R2? We have write down the elements of R2. 2, 3, 1, 2, 3, 1, 2, 3, 1, minus 1, 0, minus 1, 0. Again, since here A2 is outgoing, we can remove this A2 from this table. A2 is outgoing, we can cancel A2. Then what are the elements? 2, 3, 1, minus 1. Then minus 1, 0, minus 1, 0, minus 1. Minus 1, 0, minus again 0. Okay. Now let us divide each and every element by 3. If we divide by 3, what you will get? This is 2 by 3 or 2 dash 2 by 3. 3 by 3 is 1. This is 1 by 3 minus 1 by 3 0 minus 1 by 3 0. These are the elements. Just substitute these values for R2 dash here. 2 by 3, 1, 1, 1, 1 by 3, 1 by 3, minus 1 by 3, 0, minus 1 by 3, 0, again minus 1 by 3 and 0. So these are the elements. Now convert this minus 1 as 0. So to convert this as 0, so use this, here it is 1, we can use R1 dash is equal to, using the elementary operation, R1 dash is equal to R2 dash plus R1. Now what is R2 dash? R2 dash we have 2 by 3, 1, 1 by 3, minus 1 by 3, 0, minus 1 by 3 and 0. Now find out the elements of R1. R1 we have 1 minus 1, 1 minus 1, 1, 1, 1, 1, 1 minus 1, 1, 1, minus 1, 0, 1, minus 1, 0 and 1. Just add this. That's it. If you add, what you will get? Adding. So this is 2 by 3 plus 1. 1 minus 1 is 0. 1 by 3 plus 1. Minus 1 by 3 plus 1, comma 0 minus 1. Again minus 1 by 3 plus 0. 0 plus 1 is 1. Take LCM. 3 is LCM. 3 ones are 3 plus 2 is 5 by 3. This is 0 as it is. Again 3 is the LCM. 3 ones are 3 plus 1 is 4 by 3. This is 3 is the LCM here. 3 is the LCM. 3 ones are 3 minus 1 is plus 2 by 3. This is minus 1. and again this is minus 1 by 3 comma 1. These are the elements. Okay, let me write these values in the table. This is for R1 dash. So R1 dash is equal to 5 by 3, 5 by 3, 0, 4 by 3, 0, 4 by 3, again 2 by 3 minus 1, 2 by 3 minus 1, again minus 1 by 3 and 1. So these are the values of R1 and R2 for the first iteration table. Now as usual, find out the value of Zj and delta j. Now what is Zj? Multiply this. Minus 1 into 5 by 3 plus 0 into 2 by 3 is minus 5 by 3 as it is. Minus 1 into 0 is 0, this is 0. Minus 1 into 4 by 3 is minus 4 by 3 plus 0. Again minus 1 into 2 by 3 is minus 2 by 3 plus 0. Again minus into minus plus 1. Again minus into minus plus 1 by 3. Again minus into plus 1, it is minus 1. Now find out the value of delta j. Delta j is equal to Zj minus Cj. Now this is 0 minus 0 as 0 as it is. This is minus 4 by 3 minus 2 by 3 as it is. 1 minus 0 is 1. 1 by 3 minus 0 is 1 by 3. Again, see this. Minus 1 minus into minus plus 1. This is equal to 0. Okay. Now, since we have two negative values, therefore the optimality is not reached. To find out the least negative, just find out the incoming and outgoing variables. That's it. Now, just find out the least negative value. Since here the optimality is not reached, again we have to go for one more iteration. Here the incoming variable. So the least negative is this. This is the incoming variable. Incoming variable is x2 is the incoming variable. So therefore these are the incoming variables, and find out the ratios. The ratio is equal to x0 divided by the incoming variables are x2. x0 divided by x2. Now what is x0? x0 is 5 by 3. 5 by 3 divided by x2 is 4 by 3. So this is 5 by 3 into 3 by 4 gets cancelled, 5 by 4. Now the ratio is 5 by 4. So I'll write 5 by 4 here. 5 by 4. 5 by 4 is also equal to 1.2. Now similarly, x0 is 2 by 3 divided by 1 by 3. So 2 by 3 divided by 1 by 3, 3 gets cancelled, 2 by 1 is equal to 2. This is 2. So the ratios are 1.1 and 2. As usual, find out the least positive value. The least positive value is 1.2. So therefore, these are the outgoing variables. Outgoing variables. So here the outgoing variable is A1. So just these are the outgoing variables. So here x2 is the incoming, A2 is the outgoing variable. So here in the next iteration, this A1 is replaced by x2. For the next table, just find out the key element. Here the key element is, what is the key element? 4 by 3 is the key element. Key element is equal to 4 by 3. Now just convert this 4 by 3 by dividing the row, entire row by 4 by 3. So then this will convert to 1. Convert 4 by 3 as 1 and 1 by 3 as 0 by using the elementary row operation in the next iteration table. So now I'll go to the next iteration table. Convert this 4 by 3 as 1 by dividing the entire row by 4 by 3. Now let us come to this. R1 dash is equal to R1 divided by 4 by 3. So that is equal to, what are the elements here? We have 5 by 3. 5 by 3, comma 0, comma 4 by 3, 2 by 3 minus 1, comma minus 1, minus 1 by 3. Now divide each and every element by 4 by 3. So what you will get, this is also 4 by 3, this is also 4 by 3, 4 by 3 and 4 by 3. So here 3 gets cancelled, this is 5 by 4. 0, this 2 gets cancelled, 1, 3 gets cancelled, 2 2s are 1 by 2, this goes to the numerator, minus 3 by 4, 3 gets cancelled, minus 1 by 4. So these are the values we are going to get. I will substitute this in the table 2. In the iteration 2, A1 is replaced by x2. So a1 is replaced by x2 and the coefficients of x1, x2 are 0 and 0. Now r1 dash is equal to, these are the elements, pi by 4 r1 dash, this is r1 dash, pi by 4 0 1 0 1, then 1 by 2, then minus 3 by 4, then minus 1 by 4. These are the values. Now let us come to the next one. Convert this 1 by 3 as 0. For this, the operation we are going to use is r2 dash is equal to, now r2 dash is equal to r2 minus 1 by 3 times r1. So that is nothing but, let us write down the elements of r2. r2 are 2 by 3 1, 2 by 3 comma 1, comma 1 by 3 minus 1 by 3, 1 by 3 minus 1 by 3, again 1 by 3 minus 1 by 3, 0 and minus 1 by 3. These are the elements. Now multiply this with 1 by 3. Let me multiply this with 1 by 3. Okay, 5 ones are 5 by 3 fours are 12. Again 0 into this is 0. 1 into 1 by 3 is 1 by 3. Okay, 1 by 2 into 1 by 3 is 1 by 6. 3 gets cancelled, minus 1 by 4. Again minus 4 3s are 12. Now subtract this, that's it. If you subtract, what you will get? 2 by 3, 2 by 3 minus 5 by 12. Take LCM, 12 is the LCM. 3 4s are 4 2s are 8 minus 5. 8 minus 5 is 3 by 12. This is equal to 3 1s are 3 4s are 1 by 4 you will get. Okay, right. So this is 1 by 4. 1 minus 0 is 1. 1 by 3 minus 1 by 3 is 0. Again this is minus 1 by 3 minus 1 by 6. So take LCM, 6 is the LCM. This is minus 2 minus 1 is minus 3 by 6 means minus 1 by 2. This is minus 1 by 2. 0 minus into minus plus. Again minus 1 by 3 minus into minus plus 1 by 12. Take LCM, 12 is the LCM. Minus 4 plus 1 is minus 3 by 12 is 3 1s are 3 4s are minus 1 by 4. So these are the values. Let me substitute these values in the table. So what are the values? 1 by 4. Here it is 1 by 4. Then 1 0 1 0. Again minus 1 by 2. Minus 1 by 2. 1 by 4 and minus 1 by 4. These are the values. Okay. Now just find out the value of delta j and zj. Now first find out zj. So here, just here, multiply these elements. 0 into this is 0. Again this is 0. Everything will get cancelled. You will get it as 0. See, since these two are zeros, if you multiply and add, you will get 0 0. So again these are also equal to 0. Since all the values of a2 are cancelled and the value of zj is greater than or equal to 0, they are all equal to 0. So then what is the conclusion? We can say that we will go for phase 2. In phase 2, the initial table is constructed with basic variables as x1 and x2 was present at the solution stage. So we have to go for the next phase, phase number 2. Here the coefficients, what are the coefficients? The basic variables as x1 and x2 was present at the solution stage of the phase 1. Ignoring the artificial variables a1 and a2, assuming 0 coefficients for s1, s2, s3 and taking the original coefficients of x1, x2, x3 as given in the original problem for max z, then coefficient of basic variables and the coefficients in the next iteration table. In the phase 2, we are going to construct the table by using the standard form. The standard format of the problem phase 2 is max z bar is equal to, or max z star is equal to minus 10x1 minus 6x2 minus 2x3 plus 0s1 plus 0s2 and subjected to the constraints minus x1 plus x2 plus x3 minus s1 is equal to 1, 3x1 plus x2 minus x3 minus s2 is equal to 2, where x1, x2, x3, x1, s2 are all greater than or equal to 0. The coefficients are the same for this. Okay, let us come to the next table. In the next table, write down the coefficients of x1 and x2. The coefficient of x1 coefficient is minus 10 and x2 coefficient is minus 6. and the values for this are from the initial table, that is from the table number 2, iteration number 2. So the same values I am going to take. 5 by 4 0 1, 5 by 4 0 1, 1 by 2, minus 3 by 4 and minus 1 by 4. So for the second row, the values are 1 by 4 1 0, 1 by 4 1 0 and minus 1 by 2 plus 1 by 4, minus 1 by 2 plus 1 by 4 and plus 1 by 4, that is minus 1 by 4, minus 1 by 4. So these are the values. Now for as usual, find out the value of delta J. Now multiply these two. Minus 6 into 5 by 4 plus into minus minus 10 into 1 by 4. Take LCM, 4 is the LCM, 6 5s are 30, minus 10, minus 40 divided by 4 is minus 10. So the first value here it is minus 10. Again 0 into 6 is 0, minus 10. Again minus 6 into 1 is minus 6. Again 0, this is minus 6. Minus 6 into 1 by 2, minus 6 into 1 by 2, minus into minus plus 10 by 2. So this is nothing but minus 3 plus 5. 5 minus 3 is 2. Again the next value is minus 6 into minus 3 by 4 minus 10 into 1 by 4. Take LCM, 4 is the LCM, minus into minus plus 6 3 is 18 minus 10. So this is equal to 18 minus 10 is 8 by 4, that's equal to 2. Here this is also 2. Again the last value minus 6 by 4, minus into minus plus 6 by 4, again minus into minus plus 10 by 4. Take LCM, 4, 6 plus 10, that's equal to 16 by 4, 4 4s are 16. This is 4. These are the values. Okay. Now find out the value of delta G. So this is minus 10 plus 0, minus 6 into plus, minus 2 plus 2 is 0, again 2 minus 0 is 2, 4 minus 0 is equal to 4. Since all the values in delta J are greater than or equal to 0, see here this is greater than or equal to 0, all are positive value, hence the optimality is reached. Therefore the optimality is reached. What are the values here? So therefore the values of x2 and x1 and x2, here x1 is equal to, the value of x1 is 1 by 4 and x2 is equal to 5 by 4. So x1 is equal to 1 by 4 and x2 is equal to 5 by 4, and maximum z bar is equal to maximum of z dash is equal to, what is the value we got it here? Minus 10. So this is equal to minus 10. So since the given problem is of minimization, therefore minimum z is equal to minus of minus 10 is equal to plus 10. So therefore minimum z is equal to 10 at x1 is equal to 1 by 4 and x2 is equal to 5 by 4. This is the solution for the given problem. So this is how we are going to solve a LPP using two-phase method. That's it. Okay. Hence conclude, therefore yes, z minimum is equal to 10 at x1 is equal to 1 by 4 and x2 is equal to 5 by 4. This is the required answer. So if you want to verify, you can go for the initial problem. What is the problem given? Yes, this is the problem given, that is minimum of z is equal to 10x1 plus 6x2 plus 2x3. So if you substitute the values of x1 and x2, what are x1 and x2? x1 is 1 by 4, x2 is equal to 5 by 4. x1 is 1 by 4, x2 is equal to 5 by 4. This is equal to 10 into x1 is 1 by 4, 6 into x2 is 5 by 4 and 2 into x3 is 0. Here x3 is not there, x3 is 0. So we can write, so 10 by 4 plus 5 6 are 30 by 4, that's equal to 4 LCM, 40, that's equal to 10. So therefore Z minimum is equal to 10 at x1 is equal to 1 by 4, x2 is equal to 5 by 4, and x3 is equal to 0. This is how we are going to verify. Therefore, the minimum of Z is 10 at x1 is equal to 1 by 4, x2 is equal to 5 by 4, and x3 is equal to 0. At x3 value is not there, that is equal to 0. Okay. So, this is how we are going to solve a LPP using two-phase method. Hope you followed. So, that's all for today's session. Let us meet with a different concept in the next class. Thank you. Thank you very much.